Friends, get ready for a journey that will shake your understanding of the universe. We are heading to a corner of our solar system where nature reveals its most violent form. We're talking about Io, Jupiter's closest moon. This is no ordinary place. It's a world where volcanoes spew fire thousands of kilometers into the sky, where oceans of lava flow, and the landscape resembles a version of hell. Today, we'll uncover the mysteries of Io, understand the science behind its astonishing volcanic activity, and explore whether life could ever arise in such a burning world, where everything is so drastically different. Introduction to Io. So let's get a closer look at Io. Io is one of Jupiter's 4 large moons. Discovered by Galileo in 1610, this moon is slightly larger than Earth's moon, and it's the most geologically active object in our solar system. Io is one of the most unique moons in the solar system. Its discovery played a key role in expanding our understanding of the cosmos. Galileo's discovery of Io supported Copernicus's idea that Earth is not the center of the solar system. Before this, people believed that all celestial bodies revolved around Earth. Io is named after a character in mythology. In Greek mythology, Io was a mortal princess. Studying Io is very important for scientists. It helps us understand how planets and moons form and evolve. It also shows how tidal forces can affect the geological activity of celestial bodies. Moreover, Io's study may help us determine the potential for life in extreme environments. Formation and history. Io's history isn't just about volcanoes. It tells us a lot about the early days of the solar system and how objects within it formed. It is believed that Io formed around 4.5 billion years ago, alongside Jupiter and the other Galilean moons. At that time, the solar system was a huge rotating cloud of dust and gas. Materials within this cloud gradually clumped together to form planets and moons. Initially, Io wasn't very volcanically active, but as it came closer to Jupiter, the tidal stress increased. Io's elliptical, egg-shaped orbit means its distance from Jupiter constantly changes. When it's closer, gravitational pull is stronger and weaker when farther. This changing force constantly squeezes and stretches Io, generating internal heat through friction. This process turned Io into the most volcanically active body in the solar system. Structure, volcanoes, and environment. Io is a complex and dynamic world. Its structure and history make it different from other moons. Io's structure and environment are extremely harsh, but that's what makes it so fascinating. Io's volcanoes don't just spew lava but also sulfur and sulfur dioxide gas that spreads hundreds of kilometers into space. These plumes affect Io's thin atmosphere and Jupiter's surrounding environment. Scientists have observed various volcanic features on Io. Lava flows, rivers of molten rock stretching across the surface. Lava lakes, massive pools of molten lava, such as Loki Patera. Plumes, volcanic eruptions that shoot gas and dust high into space. Io's surface is made of different sulfur compounds, which appear in yellow, red, orange, and black depending on temperature. Its volcanic activity is also driven by its thin atmosphere that is constantly formed by volcanic gases but continuously leaks into space. Scientists believe Io's interior has multiple layers: a core of iron or iron sulfide, a molten silicate mantle, a crust made of rock and sulfur. Io's internal heat and volcanic activity are caused by its tidal interactions with Jupiter. Originally calmer, Io heated up as it got closer to Jupiter, causing extreme volcanism. What lies beneath Io's surface? Scientists believe Io has a molten interior, a major reason for its intense volcanic activity. Its core is likely made of iron or iron sulfide, surrounded by molten silicate mantle, and a crust made of rock and volcanic materials. This crust is constantly renewed by volcanic activity, which is why Io has very few visible impact craters. Understanding Io's interior helps scientists learn how tidal heating works, and how it affects planetary geology and volcano formation, not just on Io, but elsewhere too. Why are there so many volcanoes on Io? The answer: tidal heating. Jupiter's immense gravity exerts strong pull on Io. Io's orbit is not perfectly circular and experiences gravitational forces from Jupiter and the other Galilean moons, Europa, Ganymede, and Callisto. These varying forces constantly squeeze and stretch Io. This squeezing creates internal friction, heating its interior, and causing volcanic activity. Io's orbital resonance with Europa and Ganymede amplifies these tidal forces even more. Tidal heating is a powerful process. making Io the most volcanically active object in the solar system. Io is squeezed and released like a ball, a process known as tidal flexing. Unlike Earth's volcanoes, which are powered by radioactive decay and residual heat, Io's volcanoes are powered by tidal heating, a much stronger and unique process. This constant resurfacing wipes away old impact craters, leaving a smooth but fiery terrain. Could life ever exist on Io? It may sound strange, but scientists are seriously considering whether life could exist on Io. Io's surface is incredibly hostile, with extreme temperatures, high radiation levels, and a lack of water. However, some experts believe the subsurface might host conditions that could support life. We need to examine whether the necessary ingredients for life are present. A liquid solvent, like water, is crucial. There's no water on the surface, but there might be subsurface water ice or other exotic fluids like sulfur dioxide. Energy: most Earth life uses sunlight, but Io's surface gets little light and a lot of radiation. So life would need another energy source, possibly chemosynthesis, or geothermal energy from tidal heating. Organic molecules: none have been found on Io's surface, but they might exist beneath, shielded from radiation. Life takes time and a stable environment to evolve. While Io's surface is unstable, there may be subsurface pockets with more stable conditions. On Earth, hydrothermal vents on the ocean floor support life. Without sunlight, using chemosynthesis. Similar systems might exist below Io's surface. Also, lava tubes, tunnel-like structures formed by lava, could offer stable temperature and low radiation. If these exist on Io, they might be potential habitats for microbes. Some scientists also think water ice beneath the surface might be left over from Io's formation or delivered by other icy materials. If melted, it could offer the liquid medium life needs. All these ideas are just theories. We have no concrete proof of life on Io, but the possibilities are exciting. Io reminds us that life might exist in places far more extreme than we ever imagined. Like this video? Subscribe to the Astro Talk for more mind-blowing space questions, facts, and theories.